Lewis' theory of acid and bases.
Edward Newton Lewis was an American physical chemist known for the discovery of the covalent bond and his concept of electron pairs. His Lewis dot structure and other contributions to valence bond theory have shaped modern theories of chemical bond. Lewis successfully contributed to the thermodynamics, photochemistry, and isotope separation, and is also known for his concept of acid and bases.
In 1923, he formulated the electron pair theory of acid-base reaction. In this theory of acid and bases, a Lewis acid is an electron pair acceptor and a Lewis base is an electron pair donor. This year, he also published a monograph on his theories of the chemical bond based by the work of J. Willard Gibbs. It was known that a chemical reaction proceeds to an equilibrium determined by the free energy of the substances taking part. Lewis spent 25 years determining free energies of various substances. In 1923, he and Merle Randall published the results of this study, which helped formalize modern chemical thermodynamics.
And now we will show
the theory of acid and bases of Lewis.
A Lewis acid is an electron pair which can accept electrons, and a Lewis base is an electron pair which can donate it. Now let's watch this equation. SO3 plus water forming sulfuric acid. Did you know this is also the equation that forms when acid rain is forming? So now, let's see how this equation works. We have 3 oxygens in SO3, but we also have 4 in H2SO4, which means that 1 oxygen of HO2 has moved to SO3. But how can this happen? The lone pair of oxygen in the water will attach to the SO3 and that bond pair will be found in the product, which is H2SO4. The electron pair in water was donated by and it was accepted to SO3. For this reason, we can consider that SO3 is the Lewis acid, now that it was able to accept an electron, and water, HO2, is the Lewis base, now that it was the electron donor. The Lewis theory suggests that acids react with bases to share a pair of electrons, with no change in the oxidation numbers of any atoms. Many chemical reactions can be stored into one or the other of these classes. Either electrons are transferred from one atom to another, or the atoms come together to share a pair of electrons. The principal advantage of the Lewis theory is that the way it expands the number of acids and therefore the number of acid-base reactions. In the Lewis theory, an acid is any ion or molecule that can accept a pair of non-bonding valence electrons. In the preceding section, we concluded that L3 ions form bonds to 6 water molecules to give a complex ion. The Lewis acid-base theory can also be used to explain why non-metal oxides such as CO2 dissolve in water to form acids, such as carbonic acid H2CO3. I hope you have understood the Lewis acid-base theory. Bye!